Okay. Next slide ni pula. Alright, semua nampak slide? Everyone can see the slide now?
Yes, doctor.
Okay.
Yes, doctor.
Thank you very much. Okay. Alright, so at this point, sekejap saya nak tutupkan WhatsApp ni. Okay, at this point, we have learned the introduction of the high voltage, the importance of the high voltage breakdown in the gas, solid and dielectric. And then next chapter 3, we have learned about the how to generate the high voltage AC, DC and impulse. Okay, these are three main high voltage source that been used in practice. Okay. Okay, for the transmission, for power distribution, we just use the most conventional approach is just high voltage AC, but we will use the high voltage DC as well as impulse for other purpose, like testing, like measurements, monitoring and so on. Okay, and then okay, for this week, for the next chapter, we're going to look at the once we generate the high voltage, and then how we can actually measure the high voltage and measure the high voltage source. So for this week, for this chapter, we're going to look into the high voltage measurements, again in three different source, which is AC, DC and as well as impulse. Okay, I think this is a very light topic, not many calculation, it's just a theory of fundamentals, and we are not focusing on the measurements probe, because the measurement will involve probes and laboratory work. Okay, it's just some introductory knowledge to you. We're not doing maybe I have later on videos on the YouTube just to show or to introduce to you some of the measurement apparatus involving the high voltage. Okay, high voltage measuring system. Okay, why we need to measure the high voltage? Okay, why we need to measure the high voltage is, first, of course, because we generate the high voltage, we need to know the value of the high voltage. That's why we need to measure the high voltage. Okay, whenever we generate a certain value, a certain source of high voltage or voltage generation, we need to know the magnitude of the voltage. That is the reason why we need to measure the high voltage. Okay, other than that, if you can see here, we need to test a high voltage equipment. That's why we need to measure the high voltage, because we need to test all the high voltage equipments, circuit, and all power system device, so that we can apply the right voltage for the right device, so that we don't destroy the device. For example, we have the transformer, or we have a circuit breaker rating at 33 kV. We need to know or we need to generate and to know the high voltage that been applied to the circuit breaker is actually 33 kV. We cannot apply 100 kV, we cannot apply 150 kV, because the rated voltage level is at the 33 kV. That is the reason why we need to measure the high voltage. Even though we generate, we know the value might be a certain range in 30 kV, but we need to know exactly, because we want to test the equipment. And what most important for the power system is actually for monitoring. Okay, this is the one of the monitoring for many purpose. One is for to monitor whether the supply voltage or for the power system transmission distribution are at the right rated voltage level, so that we don't experience any power shortage, we don't experience any over voltage. So the supplied voltage just at the right amount, at the right magnitude. And then we monitor the high voltage for other purpose, which on the security level, the safety level. Means that we need to monitor any leakage current. For example, this one, any leakage current from high voltage insulators, any high voltage device, any probe. We need to know whether the device or the substation, the power system distribution are working fine in a normal conditions, and we can actually prevent any abnormal scenario in which that may cause a serious problem or issues like catastrophic disaster from the explosions, from the failure of power equipment that might lead to injuries and death for a person. So these are some of the main reason why we need to measure the high voltage. Of course, when we have a value, we need to know the values. Even we have the power at electricity at home, we need to measure how the power consumption used for us to pay for the bills. That is for the TNB. But for our case, we need to know the power consumption, what been used, what been overrated or underpower-rated, to prepare for the correct or the right MCB to be used in the for the household, in the domestic applications. So every single thing need to be measured, because we want to know the magnitude for many purpose, like here for monitoring, safety, for monitoring, to ensure a normal power delivery. Okay, there are three high voltage source that we definitely need to measure, because we generate HVAC, we generate HVADC and impulse. Of course, these three source of high voltage need to be measured by a specific procedure and technique. But overall, in general, the fundamental basic how to measure the high voltage is actually as simple as current probes and voltage probe. Just like we measuring the voltage and current with the electronic circuit, except for the high voltage, of course, we need to deal with a very high magnitude of voltage and current. So we really need to have a special or extra safety or a protection device, or in other words, or maybe since the most of the probe can only measure a certain range of voltage level, we need to have some sort of divider to reduce the high voltage into a voltage level that can be read by the probe, by the equipments. Okay, how are we going to reduce the voltage from 100 or 200 kV into 10 volt, for example, 100 volts, for example, or even 1 kV? So we need some sort of extra equipment, device and circuit arrangement, so that the measurements, the voltage that appeared at the ammeter or voltmeter, the safe come to the safe tolerance and value, so that we don't destroy the oscilloscope, we don't destroy the multimeter, the probe, and etc. Okay, so basically the measurement technique is exactly the same, except like the electronic circuit, except for the high voltage, for the power system, we need extra on the protection, extra on the device that able to step down or reduce the magnitude of the voltage level to a certain tolerance. how we can actually reduce the magnitude of voltage level. How we can actually reduce the magnitude of the voltage levels. Hakim. Kejap mana tu? Hakim ada Hakim?
Ada doktor.
Buat apa? Makan air kacang ke apa?
Tadi saya baru balik daripada kedai doktor. Tutup sekejap.
Kak Hakim ni kat waktu kelas.
Baik doktor.
Asal pula kat kedai. Aduh. Okay, what from your point of view, how we can actually reduce the magnitude of voltage level to a lower voltage level? Hakim. Janganlah pula berlakon internet line tak elok pula Hakim. Cepat Hakim. Okay.
Maaf doktor. Tak dengar tadi.
Tak dengar. How can, from your opinion, how you can actually reduce the magnitude of voltage level to a low voltage level? High voltage level to a low voltage level.
Maybe we can increase the diameter of the conductor.
Sorry, say it again.
Increase the diameter of the conductor between the source and the load, I say.
Increase the conductor, the size of conductor.
Diameter doktor.
Diameter tu size lah. Lebih kurang lah. Size, diameter kan. Okay, you increase the size of the conductor and then you would expect voltage to reduce. Are you sure? The simple thing that you can reduce the voltage level kalau you belajar based on the previous lecture or previous years of studies, I know the simplest means is just by using the transformers, right? Daripada tinggi kepada rendah, you can actually use the transformers. Okay, what else can you reduce the high voltage? The voltage level from one level to another level. One is the transformer. The other one, how we can reduce? By using voltage divider. Right. What else? These are two most popular approach to reduce the magnitude of voltage. I'm not talking about voltage, high voltage. If you are talking just on the voltage, we can reduce it by using the transformers and the voltage divider. Okay, voltage divider can be made of capacitant, can be made of resistive equipment. And then these are the technique or the approach that we're going to look in this session. How we going to measure the high voltage so that we able to measure the high voltage so that we can obtain the measurements. Okay, with the two fundamental of transformers and voltage divider. Okay, voltage divider. Alright, okay, so now we look at the high voltage alternating current. Okay, if I to ask you which one is more treacherous, which one is more vulnerable, more dangerous, AC or DC? High voltage AC or DC? Mio?
AC doktor.
AC? Okay, kenapa Mio? AC, why you think AC is more dangerous compared to DC? Laju cakap tadi Mio. Takkan tak ada jawapan. Why? You are the final year ni. AC, DC pun kita tak dapat tahu lagi mana lagi lebih bahaya ataupun mana lebih vulnerable ataupun mana lebih risiko lah. Apa-apa calik je lah Mio. Yang you rasa? Mio. Jawab Mio.
Ya.
Kita mana
Okay.
boleh simply petik, tak ada. Awak nak makan nasi dengan mi pun awak tahu alasan dia why. Okay, Abashir Jama. Yahya Abashir Jama.
Yes, Doctor.
Yes. Yahya, what do you think? AC versus DC, which one is more
AC, Doctor, AC.
AC again? So why? Reasons?
The frequency of the alternate current is the main reason for the several effects of the human body.
Alright. Why we have the several effect to the human or everything is just because actually we mainly use the AC instead of DC. Okay. I think if okay, saya tanya seorang lagi lah. Aliauddin. AC DC. Aliauddin. Balarajan.
Doctor, DC, Doctor, because the current is high and it's also constant, while the AC is alternating current. We can escape from it if we get shock means.
Alright, okay. Balarajan cakap DC. Tengok ni pula saya nak test Kartik. Kartik,
There's a AC code.
you AC. Wah. And last one, I want to ask Muhammad Abdullah Awad. Muhammad.
Sir, saya pun rasa AC, sir.
AC juga main rasa-rasa you all sedih.
Sebab body kita macam good capacitor, sir. So AC lagi easy to penetrate.
Ni siapa? Kartik Sebab saya tak
Ada,
nampak.
sir. Siva.
Siva. Saya tak nampak your slide tau. Sebab saya tengok slide je. Saya punya komputer problem, so saya tak dapat tengok Google Meet siapa yang cakap. I just call randomly sahaja. Okay seorang je cakap DC so far. Balarajan je seorang. Okay, sadly to inform you kalau at this level you still not sure whether which one is mana lebih bahaya, mana lebih treacherous, mana lebih risk, mana lebih high maintenance adalah AC ke DC. Sangat sedih lah for power system, for electrical engineers ataupun electrical student. For me this is very serious things. In case you've been called for an interview and then they ask you simple thing like this, I think I worried they doubt about your knowledge and etc. So it's okay. So to be honest, it's actually DC. DC. What Balarajan explained to us just now, justify is accurate, is right. So just imagine. AC, we have alternating current. You will have up and down in a sinusoidal wave. But for DC, you will have a constantly at that level. Okay, for AC, we will have RMS values. But for DC, we fix at that particular value. So at every single second, the magnitude will just at 1 kV. For example, at 1 kV. While for the alternating current, it will goes up and down. Okay, that is the reason why alternating current been used widely in practice. Okay, sebab tu less risk, less risiko, less hazardous, and again for if we going to have a constant voltage or current at a very high value, the insulating will be different. Like the power equipment will be different. Means that Okay, a simple analogy for a simple for a DC for 1000 DC volt, 1000 ataupun 1k DC volt may require something equivalent to 150 or 200 or 2000 volt or 2k alternating current. Something equivalent means that because of the safety, because of the constant voltage level, it constant at a fixed amount, at a fixed magnitude values. So the answer is actually DC. Okay, that is the reason. Okay, although one of your friends mentioned before, because alternating current cause severe to the body, human injury. It just because we use AC in practice. You will have AC at your home. You will have AC everywhere. That's why we will not have the DC. Only in certain applications like you will have a DC shower pump. We are moving toward that one, DC power shower pump, because we can minimize the noise, etc. But for normal, we'll just use AC. And if you are using DC, the heat loss, the current loss, the losses will be more as compared to the AC. This is basic. Okay, so please review and take it as a trigger point for you to look further on this matter. I just worried if you go for the power utility provider, they came across these simple questions and we unable to respond it in the right way, then they might doubt of your degree level. So we are talking about the high voltage alternating current, high voltage AC, because this is the one that been widely used in power system. Even the transformer will be AC, in the substation will be AC, everywhere is AC. So we need to know how to measure the AC. Okay, we have several technique and procedure, as I mentioned before. Out of all 6 procedure, the basic fundamental is we are about to use the equivalent transformer device arrangement, or what we call it voltage divider, capacitance divider, and then other than that is electrostatic and spark gap. We will look into every single of this in the extra detail. Okay, but don't worry, for the measurement of AC, this topic, this chapter is very light. It's just introduction. It's just introduction knowledge to you. Because measurement, as I've mentioned before, we will perform in the lab. How to perform the measurements, the probe in the lab. But I think we don't have the high voltage lab. I mean, as a module, so maybe you haven't got an opportunity to perform the measurement in the lab. Okay, series impedance voltmeter. Okay, series impedance voltmeter. As I mentioned before, the basic fundamental will be voltmeter and ammeter. This is the fundamental. We will use the same thing, except for the high voltage, we need to ensure that we provide the right range of value to the voltmeter. Means that if the voltage is 10 kV, we really need to reduce the voltage to for example, 10 volt. Okay, how we can reduce that? Again, as I mentioned, by using the transformers, by using the voltage divider. Okay, then we should be able to measure the voltage level. Okay. Okay, by using the impedance voltmeter, as simple as impedance, as we know, it is a combinations of resistance plus reactant. Okay, so for power frequency AC, it can be a pure resistant or a purely reactant. So if we are using this technique, we will experience, we really need to have a, we really need to use the high resistance value. In other words, high resistance ni, high resistor lah. Okay, you nak measure simple circuit, you letak resistor. Okay, we place the resistor in the circuit to minimize the current flow. From there, you can actually measure the voltage. But in this case, we are not talking about 10 ohms, 20 ohms. We are not talking about 100 or 1 kilo ohms. No, we are talking about mega. Okay, mega ohms. 1000 mega ohms untuk level high voltage level. When the value is extremely high, a very high value, because we are dealing with high voltage, so this will trigger for other problem, which is heat temperature. Okay, of course, when the current flow over even a conductor pun, if you realize, if you run a heavy machinery equipment, or if you run even your laptop, I do believe that you can feel the heat from the adapter, the heat from the cable, etc. Right? But just imagine this one is, we are talking about high voltage, so the resistance that absorb the heat and heat dissipation from the resistance will be very high. And when the heat cause the resistance to become when the resistance due to current flow, that will cause the impedance. Impedance will be different. The impedance value will be different. That will cause again discrepancy on the measurements. Okay, series impedance, as simple as, okay, we have two end here, and then we place a resistor. Of course, in series, we have the high voltage point. Say for example here we have a high voltage point, this is low voltage, and we place a resistor across this one. Okay, across these 2 points, and then we should be able to measure the voltage by simple circuit. Okay, the voltage level here, the resistor values here is very high, like mega. And since the effect of the thermal heating, Joule heatings, and then we're going to have the stray capacitance and inductance, C and L, in the circuit. So we also need to consider this as part of the calculations. Okay, don't worry about the calculation now. It's just fundamental things in which the total impedance will be R plus J omega L, divided by 1 minus LC plus CR. CR is resistant, C is capacitance, L is the inductance. These are the formula to obtain the total reactant. From there, we can proceed with the calculation. So basically, we place the impedance at the point between the high voltage and low voltage. From there, we can put a probe to measure the voltage drop across the across the impedance. Okay, next, we have the impedance. We can actually use the capacitance. Impedance, reactant, capacitance. We can use this kind of approach by using a capacitance. Okay, we have a high voltage point here, and we have a ground terminal. We place here between the high voltage and ground, we place a capacitance. Okay, and along in series with the capacitance, we place the ammeter. This is where we measure we measure the high voltage. Means that from this value, it can be converted into the high voltage value by the multiplications. Later on, I'll show you how people, how the engineers obtain the measure the very low values here, and then they convert it into the high voltage due to multiplications. This one. So as for safety, because this one is related to the current capacitor, charging capacitor, they will provide a protective cap. Here we have the some sort of fuse, some sort of any protective device that will break, that will disconnect, or if anything happen to this one, the current will flow through this point. This is the protective guide to protect the ammeter. So basically, again, how we measure this one is by using series reactant previously, and series capacitant, in which we place the capacitant here, and then we measure the current. Okay, number 3. Okay, this is, to be honest, this is the most popular one that been used in practice. The most popular approach, the most popular technique that been used in practice in the lab as well. Okay, we will use the capacitant or potential divider, or we can call it voltage transformer. This is what I told you before. The fundamental to measure the voltage and high voltage is to reduce the very high magnitude to a smaller range of voltage, so that it's become measurable by a probe. Okay, normally about 100 volt. 100 kV will be reduced to 100 volt, so that it's become measurable by the probe. That is the only way that we can measure the high voltage device. Okay, I nak tanya, I would like to ask you a soalan cepu mas, this one. Okay, Zakwan, agak-agak why we need to use why we don't invent the high voltage probe? Zakwan. Zakwan, tadi saya panggil siapa tadi?
Ya, saya datang.
Zakwan, cepat Zakwan. Kenapa kita tak buat probe yang kita guna multimeter tu? Why we still use multimeter untuk measure high voltage?
Untuk mendapatkan nilai yang lebih accurate.
Betul. Accurate, tapi why we don't use the high voltage probe? Okay, sebenarnya this one we call it high voltage probe. Okay, and I mentioned before how we going to measure the high voltage. Nak tak nak, like it or not, we have to reduce the magnitude of the high voltage to a lower value, so that it's become measurable by a probe. Okay, jadi my question is that why we don't use the device that can measure directly the high voltage magnitude?
Untuk safety.
Okay, good. Safety. Lagi Izwan. Muhammad Izwan Ilyas.
Prevent electrical shock ataupun dari sudut price daripada material yang kita yang kita measure tu.
Betul. Okay, safety tu satu. One is safety, and what most crucial for companies is the cost. Macam siapa Izwan cakap tadi, cost. Because you nak invent things yang buat cost, yang at the end of the day high voltage kita tak measure banyak pun. That's why what they propose is actually, instead of having the high voltage multimeter, we maintain to use the normal multimeter, but what we do is we just step down the voltage level. This is what people do. They will just use potential divider, capacitance divider, or in other words, we can actually call as voltage transformer. Sama. Prinsip dia is exactly the same. You can see here, this is a shunt device, a device that been placed at the source, and then it will have like you said here, primary or secondary windings, and then from there the principle is exactly the same to the transformers, and it will reduce or step down the voltage level to a certain voltage level. If you can see here, the voltage transformer VT, voltage transformer, or we can call it potential divider or capacitance voltage divider, capacitance divider, they are just the same. Okay, they are just the same. So if you can see here, this we will have this voltage transformer at a substation. Depend on the rating. Okay, for example, this one can be 11 kV, and this one is maybe 33 kV, and this one is 100 kV. That depend to the voltage level and voltage rating. So from here, we have the voltage transformer here. We apply the high voltage here, and the voltage that coming up from here will be like we apply 10 kV, and the voltage coming up from this output will be 10 volt. Okay, and with the 10 volt, we measure by using the normal oscilloscope. We are using a normal probe, by using a normal multimeter, means that it will indicate 10 volt. Or if we see the probe is showing the 10 volt, then we know the high voltage source is actually 10 kilovolt. Okay, as simple as that. Okay, this one can be very high, as high as human 1.5 meter, human normal human height, or maybe more. Okay. Okay, why engineers tend to use this one? Why we use this voltage transformer in practice in the lab, and it been widely used around the world. Okay, first is simple design. We have a capacitance, two capacitance value or two resistive value, and then by concept of voltage divider, that one the high voltage will be reduced. As simple as that. No tricky. It very straightforward. Easy installations. Yes, once we have the device, the equipment can be placed on a wheel that can be pushed anywhere we want, except it is not really mobile, because the voltage transformer can be very heavy. It need to be permanently in the substation, permanently in the lab. It's not like transportable. Means that you cannot just simply take the voltage transformer, place inside the car, and bring it anywhere you want. That is only possible for a small scale. Okay. And then other than that, it is frequency dependence, because we are talking about transformer. Transformer not really. It can be isolation. It can provide the isolation between the high voltage and low voltage transformer, because the concept of the transformer is actually the induced voltage. The induced voltage, they are not touching each other, but the induced voltage is actually the one that make the voltage source at the input and output. Okay, if we have the input, the voltage at the output will be due to induced voltage that happen within the transformer. You can read yourself here. And of course, the disadvantage, apart from is heavy and permanently, the voltage ratio. Because we are dealing about the mega ohms level and high voltage, the voltage ratio is not that something very sensitive, and they are vulnerable to temperature variations, because when we are talking about the high voltage, there will be current flow, and the current flow will cause the Joule heating. Joule heating will give rise to the temperature, and we may experience the problems of ferroresonance in power system, because the coil and winding will lead to ferroresonance phenomena in the power system. Okay, but normally for the high voltage, for the measurement purpose, this one is still acceptable, because what happened, we are talking about 33 kV, and we just want to monitor the measurement value to ensure that the value doesn't go below the 30 kV or 25 kV, or maybe the voltage doesn't go beyond 40 kV. We are talking about kV values. We are not talking about uh, uh, like voltage 10, 15. So sensitivity level is not really important in this case. Okay. Okay, other than that, we have electrostatic voltmeter. Okay, by its name, we can see voltmeter is of course to measure the voltage, but the mechanism here is by using the electrostatic. Electrostatic. How it's work is actually we have a ring, okay, ring, and the electric field generated from the high voltage will trigger the spring either to lower or to pull, and then that spring will pull this scale to a set to any value, to any calibrated values. Okay, so small displacement of electrode is sufficient for voltage measurement. Maksudnya we can really see lah, we apply the 10 kV and then the spring will move due to the electrostatic effect from the high voltage source. And then advantage, disadvantage. Okay, low loading effect. Because why low loading effect? Because the fundamental or the working principle of this one is solely based on electrostatic. So there is no loading effects, and then it can be very high resistivity. So when it is a high resistivity, so it will create a problem of power losses. Okay, mainly due to the insulating material. Okay, so power losses dia due to insulating material. And for disadvantage of this one, application. Okay, due to load capacitance. Okay, it limited to a range of frequencies, and then with limited range of frequencies, like normal power frequency 50 Hz still okay, but when we try to change the frequency, the electrostatic voltmeter may not be applicable in this case because the change of frequencies values. And for to be used in the testing is also limited in terms of AC and DC. So even myself and I never during my studies, and we never came across like electrostatic voltmeter. The one that we normally use is actually is this one, voltage transformer. This is the one that very popular, even in Malaysia, abroad, at the substation, power plant. We normally use this device, so that we don't need to spend about this simple circuit. This simple circuit may be just applicable for like a series impedance voltmeter, series capacitance is maybe applicable at the laboratory level, in which the voltage level is not so high maybe. Because what happened, we need also to prepare for the capacitance here, the high voltage capacitance and high voltage resistor. This is also very costly. To prepare this is also very costly. Okay, and then we have okay. Okay, we have a peak reading AC voltmeter. Okay, what the device do is actually it measure the AC voltmeter, the peak values. Okay, but this technique will require a destructive discharge. Okay, so you need to discharge, then only you can capture the peak value of the source. Okay, so this is also not very popular, and it will be used only on certain testing or certain criteria. It's not very popular to be used to measure normal voltage and current value. So in this case, it may be okay, if you can see here, you need to measure the dielectric strength, etc. So this is not very popular. And the last one, of course, we can measure by using sphere and spark gap. Okay, I reserve this one to explain at the last in the impulse. Okay, because impulse is closely related to the spark gap. Okay, the technique will be just the same. Okay, now we come to the DC. Okay, DC macam tadi, just before I remind you all about the treacherous level of the DC versus AC, and now from there you can see we have more than 5 to 7 techniques to measure for AC, because they are very popular and they are widely used in practice. But for DC, which is only be used on under certain criteria, very limited due to insulation level, protection level, and the safety. Okay, but apparently we still need to measure the DC current, DC voltage, because we generate the DC. Once we generate, we need to measure the DC. Otherwise, you don't know what the value, the magnitude that you have generated. Okay. Okay, we have several techniques here, and one of them is spear and gaps, spark gaps, that can be used AC, DC, and impulse. I'll reserve it later. And then the most that been used is series resistant again, and again the same technique, resistant potential divider, just like in the AC. The method technique is almost identical, except we need to be sure we are dealing with DC. We know AC, alternating current, in which the waveform is sinusoidal, up down, up down, up down, and for the DC we'll have a constant magnetic value. It will not go up and down, will fix at certain values. Okay, now we look at this approach one, series resistant micrometer. This approach is identical to the approach as a series reactant in the AC, except for this one, if you can see closely here, we apply we apply high series resistance to take very high voltage drop across it. Okay, when we are talking about 10 kV, we put hundreds mega ohms here, so that the voltage drop across this point, so that we will have a very minimal current flow at this point, flowing to the ground. Then we will apply the multimeter here, in this case microammeter, to measure the leakage current that passing through this circuit. Despite that, we still place a protective device here. Okay, we place a protective device here for safety reason. Under abnormal conditions, this protective device can save or can protect this microammeter, because all the probes, remember the micro voltmeter, ammeter, microammeter, whatever things that measure the voltage or current, that is what we call as a probe. That is what we call as probe, because probe normally will is very expensive. Okay, and we will have the same arrangement. Say for example, we have the by calculations. Okay, by calculations we have 10 kV, and we apply appropriate value of the resistance here, and then we will have like micro range current flow through this ammeter. Then that will be scaled up to these values. Then we should be able to count for the the magnitude voltage level. See, even for DC, we are talking about, we expecting, or we tend to use the micro ammeter. We not dare to compromise with the high current values, because the current will be constant. The current will be constant instead of up and down for the AC just now. That's why for the measurement we need to go for micro range values of current, because they are DC. They are DC. They are constant current flow as compared to the AC. So if we applied the same current 1 milliampere DC compared to 1 milliampere AC, the DC one will surely will hotter than the AC, and this one will get heat easily, and we may need to use a double insulation for the DC as compared to AC, just because they are DC, constant magnitude. Okay, okay, you can read the text here. Of course, the concept, as I mentioned before, we are talking about mega ohms, okay, to obtain microammeter, as I explained before, and Ohm's law, in which we can actually calculate V equal to IR, so we can actually calculate the voltage applied by the applied voltage that coming from the source. So we should be able to measure the voltage level. Okay. Okay, the protective device, if anything happen, this one will spark, and then there will be a current flow through this one, passing by this one. So the ammeter will be safe. The second one will use series resistant microammeter. Again, if you are talking about DC, they are looking at the microammeter, because we don't want to generate more currents. We don't want to generate current at a higher value level, because of the insulations, because of the safety, because of the safety levels. Again, this is a simple circuit, but since we are talking about the resistance, of course, when we are talking about the mega ohms, this one will cause high power dissipations, and then when there is a high power dissipation, will be heat loss. Heat loss will give rise to the temperature, and then some of them voltage are dependent on the resistivity level, and the sensitivity kind of mechanical stress to the device or the equipment itself. Okay, the principle is almost identical to previously that been mentioned. We use the potential divider. Okay, we use the potential divider here. Construction, we have R1 and R2 because we are talking about potential divider. When we have a potential divider, we definitely need to have two resistant value to split the voltage into two values. Okay, there will be a voltage drop across resistor 1, and then there will be a voltage drop across the resistor 2. Depend on the values, the arrangement of the circuit. So the voltage drop across the R2 or R1 can be controlled, so that one is very high and the other one is very low, so that we can allow for measurement by using probe. Again, the device is for safety levels, and if anything happen, an electrostatic or high impedance voltmeter can be used to measure the voltage across R2, as I mentioned before. If you stop at this point, review the previous several techniques that I mentioned, the concept is pretty much similar to one from another. Okay, we just need to reduce the high voltage to a lower voltage, then only can be measured by a probe. Okay, resistor potential divider. Yeah, this is maybe I would say as a recap for you. We have learned this in the electrical circuit during your first year or second year of studies. Voltage divider, V equal to V2 over R2 times R1 plus R2. For this one, you know exactly how to use how to calculate the voltage drop across a divider, circuit divider. Okay, advantage and disadvantage. Okay, more precision, because a simple circuit, both are simple for me. Except for this one, since we have two resistors, so the influence of the temperature can be reduced, can be split into two resistors, as compared the previous one been only absorbed by one, and this in this case it been absorbed by two, so the effect will be reduced. Okay, again, limitations, high power loss, we cannot deny on that because we are talking of high voltage. Leakage current, there might be a possibility of leakage current, and when we apply high voltage across a certain resistor, there might a possibility for this circuit to be flash over. If, for example, if we didn't provide enough space and right resistor values, there might be a flash over or damage across the divider. Kalau kita, if we apply the voltage level that higher than the breakdown of the air, it can easily trigger for the breakdown. That is what we call as a flashover. Okay, next is generating voltmeter. Okay, generating voltmeter, this is not very popular. Normally we'll just use a voltage divider. We have a variable capacitor, electrostatic voltage generator, which generate current. This one will generate current proportionate to the applied external voltage. Maksudnya means that we applied 10 kV, this one will generate more current. We apply more voltage, there will be more current. So this device is driven by the input voltage, and then that will trigger this device to proportionate to the output values. Okay. This is known as the generating voltmeter. It involves the motor driven by external, if you can see, driven by external synchronous motor speed, and this motor speed is depend on the applied voltage. So it means that the more we apply, the more current will be generated to the circuit. And advantage, disadvantage, for this one, no loading, no direct connection to HV electrode. Okay, because this one is driven by capacitor, by electrostatic voltage, so they are not connected to the, it can be isolations. The scale is linear. Linear means you increase 10 volt, the current will increase 1 amp or 1 milliamps. And then quite convenience, and limitation is that require calibrations. Of course, all the probes would require calibrations, and careful instructions. A disturbance in the position mounting of the electrodes make the calibration invalid, because this one we are dealing with electrostatic, and then the calibration is quite tricky, and this one involve the several electrodes that will cause a kind of discrepancy to the values. Okay, last but not least is the spear and spark gap. Spear and spark gap. This is a very popular approach as well. Apart from the voltage transformer, this is also the most that been used in practice. Okay, and this spear and spark gaps can be used to measure AC, DC, as well as impulse. Okay, potential divider again, for us to measure the impulse, as I mentioned before, we need to reduce the magnitude of voltage level to a very low voltage level. In that case, we need to have the potential divider, voltage transformer. Okay, either it is resistant or capacitance, is depend on applications and budgets, because both will have pro and cons. Okay, these are few arrangements. If you can see here, we can have many type of arrangements between the capacitor divider or resistor divider. If you can see here, A, resistor or parallel mixed capacitor divider. Okay, we have resistor and capacitor which in parallel, and then for B we have capacitor divider, simple matching. What we have here, we only apply the capacitor here, so in as a voltage divider. And then 3, we have a capacitor divider compensated matching. We use divider as from the capacitor, and this been compensated by the external circuit here. Like this one, circuit B is directly connected to the measurement device, a probe, oscilloscope. But this one, they will apply another external RNC, so that for compensated matching. And we also have a capacitor divider, again the capacitor in combination of resistor, for a simple matching. Okay, we can go for any approach that we like, and most of them will have pro and cons, and certain arrangement may only be applicable for certain application. For example, we may need to use this arrangement because of we need to compromise the sensitivity level, and we may need to use this one because we don't bother about the sensitivity, we just need the values. It depends to what test measurement that we need to measure. Okay, potential divider, error and distortion in output wave due to the problem of the potential divider will have the inductance, because potential divider we will have the stray capacitance as well, impedance error, and the oscillations due to the cables inductance and capacitance. Because the potential divider made of capacitance, and if it is made of resistance, there will also opportunity for the arrangement to trigger for the stray capacitance. Stray capacitance is actually the capacitance that is not needed, is not essential. It just exists by on its way. So we don't need that, but it's appeared. So how to get rid of them? So that is some of the challenge related to the potential divider. And again, we are talking about the high voltage. So in my personal opinion, sometimes we don't really go for the sensitivity, even though the measurement is 33 kV, even though the 33.5 is negligible, can be even though as high as 500 volt for the high voltage measurement is can be considered as negligible, because we are talking about high voltage. 500 volt is nothing. 500 consider nothing. Okay, the last one is a spear gap here. Okay, as I mentioned, it can be used to measure DC, AC, and impulse. There is a limitation in the gap distance, of course, because we using the spear gap. We cannot increase or decrease. They have a certain range that can be used, because when we are talking about spear gap, we are talking about the we are dealing with the breakdown voltage of the air. Okay, why we use this one? To provide homogeneous field distributions, so that there is no corona appeared before the breakdown. Okay, if we use the needles or a rod or electrode, there will be very high electric field at this end, and that will trigger for false magnitude. That's why we go for spear. The spear, the electric field distribution around the spear will be almost equal and homogeneous to this one and this one, and then that will cause a more accurate measurements. Okay, let's see this. Okay, spear gap can give accurate measurement with a simple experimental setup. Okay, these are we can actually place the electrode either vertically or horizontally. No problem, but it's depend to the clearance. Okay, we have the clearance here. Okay, clearance distance, and clearance, as long as we fulfill the clearance distance to avoid the spark to the to the what we call it, to the holder. So as long as that one is fulfilled, then should be okay. So we have diameter of the electrode, we have the gap, spear gap between these two electrode, and of course we will have external resistor to limit the current flow. Okay, okay, this is for verticals. Okay, they are symmetry. Okay, you can read. And the spear gap. Okay, maybe later on I'll show you some example on this one, spear gap. Okay, so okay, how it's work. Actually, the spear gap, okay, at a certain distance, for example, at 1 centimeter between these two spear gap, we know it will spark if the applied voltage is 30 kV, 25 to 30 kV, because we know the breakdown voltage of the air is actually 30 kV. So the voltage will break down at 30 kV, at the 30 kV if we put the spear gap at about 1 centimeter. If we put at 2 centimeter, the value will be different and different, so on and so forth. Okay. Okay, so far, do you have any questions so far about this simple measurement technique? So okay, so to summarize this is actually the measurements. How we measure, as I mentioned before, whatever technique we measure, we still need some sort of auxiliary or external device and equipments to ensure the high voltage value will become a low voltage values by using voltage transformer, by using voltage divider, by using uh, voltage transformer, as I mentioned before. The concept is exactly the same. And at the end, the probe that we use is actually just a multimeter, simple multimeter. But what most important, how to reduce the high voltage into the low voltage so that it's become readable. And the spear gap is different because we are working on the spear. We induce the voltage. Once it reach certain values, it will spark, and then we know, and the voltage level is certain values. Okay, that's about measurement technique, and I will show you a video here, YouTube video with explanations, and maybe you can take something from here. Okay, where is it?